Today we're going to be looking at similar figures, and we've been working on area, and we're going to take a quick peek at what happens when we have similar figures and what happens to the area. So let's start with what are similar figures. So figures that have the same shape but not necessarily the same size are considered similar figures. So if you take a look at these two, it's the same shape. If you look at it, it's the exact same shape, but this one's just bigger. So it's kind of like an enlargement. So let's write a little quick thing here. Same shape, different size, and then in parentheses, this can be an enlargement, or if you were going the other way, it could be a reduction. So they're not different shapes. Even if it was another triangle, if it didn't look exactly like this one, but just bigger, it wouldn't be considered similar. So it can't just be another triangle, another rectangle. It's got to actually have the same proportions on its sides. And we'll talk about that. So this little squiggle symbol, it's like not quite a dash, but a little squiggle, means similar to. And you can use proportions to find the missing length of a side in a pair of similar figures, and we'll talk about what that means. So here's the symbol. It says, for example, triangle ABC is similar to triangle DEF. So obviously it's not saying they're equal to each other. One's a lot bigger. But it's saying they're similar, meaning if I took this small one and enlarged it, if it was on your phone screen and you just enlarged it, it would end up looking like this. And vice versa. If I shrink this one down, it's going to look like this. So take a look at the sides and how they correlate. This side matches this one, and it went from 5 to 10, and this one matches this side, and it went from 4 to 8, and this one went from 3 to 6. So you can see the correlation. Basically, all the side lengths were doubled. And if you were going this way, all the side lengths, 10 to 5, 8 to 4, 6 to 3, were being cut in half. Okay, so you're multiplying by 2 to go this way. You're multiplying by a half to go this way. And what we can do is we can set up proportions, which are just ratios that are set equal to each other. So 5 compared to 10, we can write like this, 5 over 10. It's going to be equal to the comparison of all the other correlating sides. So 5 matches 10 the same way 4 matches 8, the same way the 3 matches the 6. And all of those equal 1/2. So since all of these ratios are equal, we would say that these are in proportion and they're similar. So let's take a look now. How do we solve for missing sides using this information? So since the two figures are similar, the ratios of the corresponding sides are equal. That's what we showed up here. So they've told us they're similar. Okay, that's important. So looking at these two, the smaller one, if you enlarge it, you're going to get this one. And notice the 7 became a 28. So since this is all similar, you can write and solve a proportion to find side ST. So what we're actually trying to find in this problem is side ST. So you got to find those letters, the side that connects them, this side. That's ST, and that's what we're looking for here. Now the numbers are simple enough that you can just look at it and figure it out. 7 becomes 28, so we multiplied it by 4. So 5 multiplied by 4, it's going to give you a side of 20. So if the numbers are that easy, you can just do it. The numbers are not always going to work out perfectly like this. Notice how 7 went into 28 exactly 4 times. It's not always going to be true. So how do we set this up if not? So we want to set up our ratios here just like we had in the first problem. So 7 compares to 28. And since these are similar, it has to equal the ratio on the other side. So we're going to compare the 5. And now we didn't have the 20 yet. Let's pretend we didn't have the 20, and we're just going to call that a variable. So we'll call it x. Okay, it looks like this. So when I'm dealing with this proportion, okay, setting up equal ratios is called a proportion. Now I can look at the numbers and I can see, okay, 7 became 28, so 5 becomes 20. But again, that's nice because the numbers are so easy. What if the numbers aren't so easy? So what you're going to do is you're going to cross multiply if they're not so easy. And what that means is you can multiply the diagonals, and they have to come out to the same number. Take a look up here. 4 times 10 is 40. 5 times 8 is 40. 8 times 3 is 24. 4 times 6 is 24. 6 times 1 is 6. 3 times 2 is 6. So when this is true and you cross multiply, you get the same number. So we can use that fact to help us find x. So what we're going to do is we're going to do 28 times 5, and I'll just give you the answer. It's 140. That has to equal this side. So 7 times whatever this is also has to give me 140. Now I don't know what it is yet, so I'm going to just call this 7 times x, or 7x. So this multiplied has to equal this multiplied. We showed that right here. So 140 has to equal 7 times whatever x is. We've set up an equation that's very solvable. If you just divide this by 7, 140 divided by 7 will give you x equals 20. So if the numbers aren't so nice that you can't just look at it and see, we're going to cross multiply, set up a simple equation, and solve it. All right, now let's talk about scale factor real quick. So scale factor is the ratio of the two corresponding sides. So when we looked up here, we said, oh, okay, this reduced to 1/2. All of these ratios reduced to 1/2. We talked about going this direction, it's times 2, and going this direction, it's times 1/2. Those numbers right there are the scale factors. It's just the factor that we're multiplying the sides by to create the new shape. So corresponding sides change by the same scale factor. That means all the sides of the small figure are multiplied by the same number to obtain the lengths of the corresponding sides of the larger figure. So going back up here for a second, all 3 of these sides were multiplied by 2 to get this. So the scale factor is 2. And going the other direction, every single one of these sides was multiplied by 1/2 to get this. So that's the scale factor going this way. So every relationship is going to have 2 scale factors, one for each direction. And if you notice the numbers, 2 and 1/2, 2 is like 2 over 1. So if I flipped 2 over 1, I get 1/2. If I flipped 1/2, I get 2 over 1. That's always going to be true. Okay, they're going to be the inverse if you flip them. So let's go down here real quick. So going from shape A to shape B, the scale factor is 3, because I'm going from 5 to 15 and 3 to 9. So going that direction from A to B, the scale factor of A to B is 3. But the scale factor from B to A going the other direction is going to be the inverse of 3, which is 1/3. This is like 3 over 1, and if you flip it, this is 1/3. Because to go from 15 to 5, I'm taking 1/3 of it. I'm dividing by 3, which is the same as multiplying by 1/3. Dividing by 3 is like multiplying by 1/3. So 9 times what gives me 3? It's 1/3. So going this direction, I'm multiplying by 3, and going this direction, I'm multiplying by 1/3. It's the inverse. All right, flip it over. So we're going to solve for the missing sides here. There's no directions, but we're just going to solve for x. So if you take a look at number 1, the numbers are easy. We're going to start off with easy problems, of course. You kind of want to find the scale factor if you can just look at it and see it. It's pretty simple. So matching up these sides, this ABC is a reduction of DEF and vice versa. It's enlarging going this direction. So this side AB matches this side DE. It went from 3 to 9. So the scale factor going this way is 3. You're multiplying by 3 to get the 9. So I'm going to do the same thing to the 5. I'm going to multiply it by 3. I'm enlarging all the sides by 3. So x equals 15. Now for easy numbers, that's fine. But what if they're not so easy? You want to set up the ratios. So 3 matches 9, so 3 over 9. And it has to equal 5 over whatever this is. So x for now. So 3 matches 9 equals 5 over x. Now just looking at this, okay, 3 became a 9. Times it by 3, so 5 becomes 15. But what if the numbers aren't so easy? We know that the diagonal products, or if you multiplied diagonally, cross multiply, they have to come out to the same number. So 9 times 5 gives you 45. 3 times x gives you 3x. They have to be equal to each other. So 3 times something has to give you the same thing as 9 times 5. So if 9 times 5 is 45, 3 times something has to be 45. You divide by 3, and you're going to get 15. So now we're going to need that here, because this one's not quite so easy. When you look at number 2, first of all, the shape doesn't look exactly the same when you first glance at it, because not only has it gotten bigger, but it's rotated, it's flipped over, but it's still the same shape being enlarged. So we need to make sure that we can kind of visualize what this looks like. So we enlarged it, but we also flipped it. So this side of 5, the straight side that hits the 90, is the same as this side. These sides match if I spin this. So 5 matches x. Let's write that down. 5 matches x. And this part right here, the 6 matches this 5. If I spin this, this becomes the top and it matches this. Okay, so if 5 matches x, 6 matches 5. Now when you first look at this, you might say, well, how does 6 become 5? Look carefully. It's inches to feet. Now if you wanted to turn inches into feet and turn this into a decimal to match this one, you could, but you actually don't have to. The relationship does not require you to do that. So 6 inches becomes 5 feet. So 5 inches becomes what? So we're going to cross multiply here. 5 times 5 is 25. 6 times x is 6x. And we're going to divide. 25 divided by 6. Oops. Plug that in the calculator. We're going to round it. Approximately 4.2. So x equals 4.2. So you can see that side length there is kind of a nasty number, so it's not something you're going to be able to do in your head. You have to set up these corresponding ratios. When you set them equal, this is called a proportion, and then you're going to cross multiply to get the answer. So match up the sides in ratios. You say that they're equal. Multiply the diagonals. And those two answers need to be equal to each other. It creates a nice easy equation for you. And it's just one more step and solve. So let's move down now. Number 3. What's the scale factor from this to this? So we're not missing any sides. We just want to know what's the scale factor. Now we're going from CAT, cat, to DOG, dog. So we're going from here to here. So before you even worry about the numbers, just look at the shape. It's getting smaller. Scale factor has to do with multiplication. What am I multiplying these numbers by to get this one? So remember, there's 2 scale factors, one each direction. They're telling you you're going from CAT, this one, to DOG, this one. So it's getting smaller. If I'm multiplying these numbers by something and it's getting smaller, it's going to be a number less than 1. So this is going to be the fraction. So if you want to think backwards, well, first of all, notice that these have flipped. If you think about it, here's like our 90. So across from 90 is 4, and across from 90 is 16. So 4 is becoming 16 if I'm going this direction. 3 is becoming 12, and 2 is becoming 8. So going this direction, I'm multiplying by 4, and the scale factor is 4. But that's not the answer to this question, because this one is talking about going from CAT to DOG. So going from here to here. Remember, it's always the inverse. So if going this direction is times 4, then that means going this direction is going to be the opposite. Well, 4 is like 4 over 1. So if I flip it, this is 1/4. I'm taking 1/4 of each one of these. So what's the scale factor from here to here? It's 1/4. Now the other way you could do that is you would actually take the numbers and you set them up. So you put the 4 over the 16. That will reduce down to 1/4. You put the 2 over the 8, that reduces to 1/4. So if you get stuck with the numbers, you can set up a ratio and it will simplify. Now how many times bigger is the area of this triangle to this one? All right, we're going to start that right on the next video.